Math 242, Cuesta College. I'm Joe Vasta, and we are going to cover section 8.1, two variable linear systems. Most of this is going to be a review. So let's see what we have here. A system has more than one equation, usually. There's two variables, and this is something you should have seen in your past. What's bugging us about this system of equations is the fact that there's fractions. So what I'm going to do to the first equation is I'm going to multiply both sides by the LCD. Least common denominator, 3, 4, and 2. That would be 12. And so when we do that, we end up getting 12 over 3, which is 4x. And then we have 12 over 4, which is 3, so minus 3y. And then 12 over 2 is 6. 6 times 3 is 18. Okay, so I'm going to multiply the second equation by its LCD, the least common denominator of 2, 3, and 6 happens to be 6. So when I do that, I end up getting 6 times 1/2, which is 3, so 3x. 6 times 1/3 is 2, 2y. And then the 6's here will cancel, and you'll end up just getting a 5. Okay, so these two equations, we just scaled them, and now they are these two equations here. And we are trying to solve for x and y. Okay, when you first learn how to do this, maybe in an algebra class, they said solve for one of the variables, plug it into the other equation, and that was cute. That's going to work. What I'm going to do is say we want to get rid of one of these variables. I'm going to choose to get rid of y. Now, to get rid of y, I'd like to have opposite numbers here. I have a -3 and a +2. If this was -3 and +3, this would be a really good thing, but it's not. So I want to get opposite numbers here, and if I were to multiply the top equation by a 2, then that would put a -6 up there. And then I can get a 6 down there by multiplying the bottom equation by 3. So let's try that out and see what happens. I end up getting 8x minus 6y equals 18 times 2, which is 36. On the bottom one, I have 3 times 3x, so that's 9x plus the 6y equals 3 times 5 is 15. So this method is called elimination because you're eliminating one of the letters. You're eliminating y because I'm going to add both of those equations together. And when I do, I end up getting 17x. This is going to give me 0y. And that's what I want. And then over here, we'll have, let's see, 11 carry the 1, 52. So we'll bring it up here. 17x equals 52. Okay, so that's not 52, is it? That's 51. Great arithmetic on my part. Okay, come on, whiteout. Do your job. Okay, this is what happens when you try to do this on a Monday. So 51. I was figuring something was not looking right. Okay, so now I'm going to divide both sides by 17. I end up getting x is 3. But I'm not done. I have to figure out what y is. So I'm going to plug this x back into one of these equations. I'll plug it into this equation before I hit it with the 3. So this is 3x plus 2y equals 5. But if you throw 3 into this equation right here, you'll get the same results. Okay, so this is 3 times 3 plus 2y equals 5. So this gives me 2y equals -4, subtracting 9 on both sides. Y equals -2. So a good question to ask is how many solutions are there? And a lot of people would say, oh, there's 2, 1, 2. But actually, there's only one solution. And that solution is the ordered pair. And our ordered pairs are x comma y. So that would be 3 comma -2. So I have one solution here. One solution. So we could say, oh, well, what did we just do? We solved the system of equations. This equation right here is a line, and this equation right here is another line. And when they say solve, what they're really asking us to do is say, are there any points that lie on both of these lines? And there is one point that lies on both of those lines, and it is the point 3, -2. Now, even though they won't ask you to do what I'm about to show you in the homework, I'm going to show you this anyway. You could actually graph these two lines, and it would be the same as graphing these two here, because all I did was scale them. So when I graph those lines, I ended up getting that right there. So that was the top line, and this was the bottom line, and they intersect right there at the point 3, -2, just like we said. So in your homework, you don't have to do the graphs, but I'm showing the graphs because I know some of you guys are picture people, and you'd like to see the picture. And let's go ahead and look at some definitions. So the definition. Now, don't get overwhelmed with this, but we do have to classify our example, and that's what they'll ask us to do. A consistent system means that there is at least one solution. Okay. Inconsistent system means there's no solution. So on ours, we had one solution. Our system here is called consistent. Okay, let's get back to these definitions. So your system is either going to be consistent or inconsistent. And then your system is either going to be independent or dependent, if it happens to be consistent. Okay, so the consistent system. So we have this diagram right here. You're either consistent or inconsistent. And if you're consistent, then if you have one solution like we did, then it's called independent. If you have infinitely many solutions, it's called dependent. So these are some linear algebra terms. They'll make much more sense if you do reach linear algebra. Our example was independent because we had one solution, so we would classify this as consistent independent. And so with these problems, there's one of three roads that you would go down. You would go down and be consistent independent, consistent dependent, or inconsistent. What does that really mean? It means when you have a pair of lines, like you do here, that when you try to find their solutions, they'll intersect and give you one solution, which is that right there. If you end up having parallel lines, those parallel lines actually have no points in common, So this is no solution, and that's an inconsistent thing. So when they meet in one place like we have this. When they don't meet, they're inconsistent, they're parallel lines. And then this is the weird one, when you have a line and then the other line is the same thing. So we can say this is the same line. And when we have the same line, how many points do they share? They share infinitely many points. You have infinitely many solutions. Now in the case of 2 dimensions, this same line thing is kind of dumb, the dependent systems. But when you get to 3 or more dimensions, then it actually gets more interesting than just being the same line. Let's go ahead and do our next example. Okay, example number 2. So what we're going to do is we're going to solve the system, and then we're going to classify it as consistent independent, consistent dependent, or the third choice, inconsistent. So let's see what happens. I'm going to choose to kill y by multiplying the first equation. I want to get opposites there. So if I multiply the first equation by 2, I end up getting 2 times 2 is 4. Well, I still don't have opposites, so maybe I should multiply it by -2. And that's a funny looking 2. So the first equation now becomes -6 minus x minus 4y equals -6. The next equation, I'm just going to leave it alone and write it right below. And then I'm going to add those equations together, and I end up killing off the y's. But here's the weird part. I end up killing off the x's at the same time. So I end up getting 0 equals 8. 14 and a -6 gives me 8. So this cannot happen. This is sort of a contradiction. So when they ask me to find the solution or to solve this system, there's no way I can get any solutions. So what we ended up saying is that there are no solutions. And going back to that, so that's an acceptable answer. Going back to this, if they ask, hey, is it consistent independent, consistent dependent, or inconsistent? It's inconsistent. So that's another way of answering it. Now, what does this look like? Okay, so if this is the first equation, and this is the second equation, I went ahead and plotted these lines on a computer. We can plot them by hand as well, but I wanted to give you a good picture. That's what those lines look like. And we said that it has no solution. That just means that they have no point in common, and those lines are parallel. Let's go ahead and do our third and final example in 8.1, and it happens to be these 2 lines right here. So I want to get opposites. Maybe I'll try getting opposites on the y. I have a -3 in front of that y, so I need a +3 there. So I'm going to multiply the bottom equation by 3. So the top equation I'm leaving alone, 9x minus 3y equals 15. The bottom equation, -9x plus 3y equals 15. The first one I said 15, but it's -15. See, I just said it wrong. I'm going to add those equations together, and I end up killing off the x's and the y's. So I get 0 for the left-hand side, and the right-hand side I'm going to get 0. Now our other problem, we ended up getting 0 equals 8, which cannot happen. But can 0 equal 0? And the answer is yes, it can happen. So what are we going to do about that? Well, what we're going to do about that is realize that these 2 equations are really the same line. Now how can we verify that? A way we could have verified this is multiply the bottom equation by a -9, and we would end up getting the top equation. So you see -9 times -3 is 9, and then -3 times. So we multiply it by -3, sorry, did I say -9? And we have -3 and -3. So it gives us the same equation. So this is really the same equation. So how do we describe all the points that these two equations have in common? Well, they're all the points that are on this equation here. So this is what I'm going to do. I'm going to take one of these and solve for one of the letters. Which letter is the easiest to solve for? Y is. So when I solve for y, I get y equals 3x plus 5. Okay, so what I'm going to do, this is going to seem a little weird. I'm going to say that x, I'm going to let x equal the letter t. T is called my parameter, okay? It's just another variable. So then what would y equal if x equaled t? Y would equal 3t plus 5. And so, remember how on the first one we had x equals something and y equals something? Well, we have that here, and we're going to write this as an ordered pair. The first one is the x value, which is t, and the second one is the y value, which is 3t plus 5. And so we are done, okay? There's a few things I want to say about this, and I'll use different ink to illustrate this. Like if t is 0, then that is the point 0, 5. 0, 5 is a point that lies on both of those lines. Look, if you put 0 in for x and 5 in for y, you get -15 equals -15, and down here you get 5 equals 5. If t is 1, you end up getting 1/8. 1/8 lies on both of those lines. Look, we have a 9 minus a 24, gives you a -15. You could check the other one as well. T equals -2 will give you another point. T equals 1/2 will give you another point. So we have infinitely many points because t can be any real number, and instead of writing all these points, all infinite points, we write our answer like this. And this actually represents infinitely many points. Another thing that we want to say is this thing has infinitely many solutions, and you can look back on that other sheet. It's going to be consistent because there's at least one solution, but it's also dependent. And that is just how it's labeled. The reason they use the word dependent is because whatever point I get depends on what value of t I choose. So it depends on your parameter. So that is what we have here. A few more things to say about this. So we were done when we wrote this, and probably that as well. Your first thing says x equals t, and then the second thing says y equals 3t plus 5. Have we seen this right here? X equals t, y equals 3t plus 5. This happens to be parametric equations. So all the stuff we've done, you know, it seems to connect together in certain ways, and we have parametric equations here. So what does this look like? I went ahead and graphed both of these lines, and remember we said they were the same line, so that's the line that I get. I get this line. And there's infinitely many points on the line. We've described all infinitely many points by saying that right there. Well, that concludes 8.1. A lot of it is a review. This part you might not remember, so do all your homework and have a good day.